Good morning, Col. How to solve exercise 3 from the Fundamentals book described in this exercise. Let's note that the system consists of two terms. We have here a Siemens in terms of Siemens and not in terms of ohms. I recommend explaining exercises 3, 15 and 16 so that you can see how or I explain in greater depth how this type of exercises are solved. And assuming that we made those escapes, I'm going to be a little faster so that the video is not too long. The first thing we are going to see is that here they tell me functional to determine in the figure, and we observe that there are 4 nodes 123 and 4. Well, that's the whole point here. In V3 these 2 nodes out of 4. So everything is fine. So I'm going to start with node B1. Here, I have to watch the columns coming in and out. That's why it gives us the sum. The columns that are going to be equal to the sum of the columns. But let's see that in the node B1 that enters. Before doing this analysis, we have to mark the direction of the currents by doing a prior visual analysis. How can we do that? If we see here this current of 6 amperes that enters here and has to take paths on one side, a part of its friend that comes to the left here and the other part here comes through this resistance. This current that comes from here reaches this point, because a part reaches the ground here. All of this is 0 volts because it is completely grounded. And it comes from here. A part goes from here and the other part comes from here. When I reach this point, this current comes here, here, and the other. Well, it will reach this point when it reaches this point. Well, a part of my work is now here. It goes up to this whole point. I say that a part comes from here. On this earth, that's a current source going into node 4. Therefore, which is the other thing, that already marks the direction of the current. Now I'm going to give them names. I'm going to call it the current, and 1 is going to be called the 2 current. 3, 4, 5, and 6. I'm going to call her. Starting from here, I have already previously indicated the reversal of the currents under analysis. I have to. The currents that enter this node, we see that there are 2. We see that it is not all the contact. 1 is the current and 2 enters the same as 5 and 2 is the same. Here it is more. Five is equal. The currents that come out plus 5 amperes, 1 constant and the other is the current and 1. Okay, now the current 2E is therefore the voltage V2 minus the voltage V1. V2 V1 multiplied by the conductance will be included. That's why we see what this conductance is like. The current is found by multiplying the message by the distance plus the current, and 5 to 45 has it here would be V4. Less V1 multiplied with this current and 2. And that has to be equal to 5 amperes to the current, and you want the current around here. All of this as V1 would be V1. V1 times 2 as 0. He organized this system. I'm going to have less V1. V2 and V1 more than 4. 5. Okay, if I move what has a variable to the same side, I mean, this would be, and as a constant alone, the result will always be minus 4 V1 V2 plus V4. That's going to be equal to 5 amps. That potion is going to put down here. I'm going to put more V2. We have to. There are no V3, so I'm going to put a 0 because there is no V3 plus 4 5. And that's my first equation. I'm going to delete. I'm going to put node B2. B2. It is clear that law 4 and the sources that appear in I, 2 and 3. And 4 as 4 times that. The conductance of the current that passes through connection 4 is at least V2. Two is equal to 42 and 2 is what it would be around here. 2 minus versus E and the current 3, that would be good, the V2 minus V1 by 1. And the 43 over here would be V2 times 2 times P2. Okay, then I start trading. It would be 4V3 4V2. Same A B2 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 and all that. I'm going to stay with V1. 7 volt plus 4 volts 3 equals. I have it here. I'm going to have that would be P1 minus 7 V2 plus 4 3 plus 0 equals 0. Communication. Let's work with equation B. From point B, there will be 3 clients that come in at 19 amps, the same as what comes out would be the past 4 plus the 7 past. So the N4 is the one that comes here, since it would be 4 times V3 minus V23 times in the V2 and plus the current, and 7 here would be one that multiplies V3 minus 2 4 that she is greater than 4 in the end. The correct would be and is equal to 6. Now we multiply V. We have 4 volts 3. This minus 4. 234 equals 6. If we organize it, whatever the variables have, then V1 2 5 0 5 0 V2 V1 minus 4 B2 B3 and minus V4 equals 6. This is my third equation. Okay, now we go to node V4. V4, the previous one was node V3194. But come on, the currents that enter V4, the 47. It's going to be equal to 5 plus the N6 plus a. Let's not forget that all that vector node. The amps also come in here. The 2 amps wrong there 762. Wrong there 77 is 1 time versus 3 minus 1 at a time, 3. It's going to be equal to the N5, the 5 that comes over here, V4 minus V1. I mean, it is. Four minus V1. And the current and 6, then the fourth, let V be 4 times 3. 3 times. Okay. So this organism is going to have 2 3 V4 or V4 V1 plus 3 times V4. Okay, then I'm going to get back to it. The question is to get that V1. If I solve for that, I'm going to get that it's going to be minus 1 minus 3 plus 5V. So equal to 2. So it would be less P1. P2 there is no recognize in B2, B3 and B4 would be more 5 volts for, so equal to it would be good to have 4 equations with 4 unknowns. I'm not going to solve it. I have minus 4 there. 1 0 and 1. Minus 4. 4 1. 0 and 8. Point. 4 1 0 and 1. 1 minus 7 4 0. 1 minus 7 4 0. 7,400 minus 4 5 minus 0 minus 5 and less, and the fourth minus 1 5 0 5. Ready. Now what you have, like it would be 5 0. 6 minus 2. 5 0. 6. And 2 5 0, 6 2. 5 0. Indeed, we have 1 and we observe that it tells me that it is minus 0.771.22.3 and 0.0706. That would be the functions of this circuit. B1 0.7 volts, B2 1.09, V 3.30, and 4. Zero point 7, 0.7, and 7. So that would be the result of exercise 3.